Welcome everybody. We are here at the 24th WFSF World Conference performing at the Humboldt Carré in Berlin, Germany. We are in the online program, last day of this great conference. So moving on, we are having some people from Brazil, right? So I'm so proud that a Latin American sister is talking about their Latin American brothers, okay? So here in this topic, we are having Alan de Oliveira Lyra, Carlos Eduardo Barbosa, Yuri Oliveira de Lima, Herbert Salazar dos Santos, Jano Moreira de Souza. Okay, so who are them? Well, Alan de Oliveira Lyra is a student in Systems and Computer Engineering at COPE UFRJ. He received the BS degree in Computer Science from the Universidade Federal do Rio de Janeiro in 2017 and received the MSc degree in Systems Engineering and Computing from the COPE UFRJ in 2021. He's also a member of Laboratorio do Futuro, Future Lab, a group of more than 20 researchers interested in exploring themes such as the future of cities, government, science, and work. Currently, the lab is part of the Brazilian node of the Millennium Project and is a member of the World Future Studies Federation. At the lab, Alan is part of the Understanding the Future research line, having published articles and technical reports. His research interests include future-oriented technology analysis, knowledge management, decision support systems, and crowdsourcing. Welcome, Alan. Then I'm going to introduce Carlos Eduardo Barbosa, who was born in Rio de Janeiro. He received the BS degree in Computer Science from Universidade Federal do Rio de Janeiro in 2006 and received the MSc and DSc degrees in Systems Engineering and Computing from the same university in 2010 and 2018, respectively. Since 2010, he has been a technologist at the Center for Naval Systems Analysis, Brazilian Navy, working as software development technical leader. In 2016, he helped found the Laboratorio do Futuro, Future Lab, a group of more than 20 researchers interested in exploring themes such as the one that I previously mentioned. His research interests include future-oriented technology analysis, knowledge management, decision support systems, and crowdsourcing. So welcome, Carlos Eduardo. Then we have Herbert Salazar dos Santos, which is a student in Systems and Computer Engineering. He received BS degree in Computer Science from the same university as the previous ones. He's also a member of Laboratorio do Futuro. And his research of the future work involves topics such as the impact of automation in Brazil, new ways of working, prospecting future work scenarios, algorithmic management, and technological assessment and professional requalification. Then we have Jano Moreira de Souza, who was graduated in Mechanical Engineering from Universidade Federal do Rio de Janeiro, Masters in Computer Science, and PhD in Information Systems from University of East Anglia, sabbatical at CERN from 1989 to 1993. He researches and teaches in computer science, focusing on the following subjects: knowledge management, social networks, CSCW, and future studies. Founder and head of the Future Lab, has supervised more than 30 PhD theses and around 100 MC dissertations, published more than 500 complete papers in journals of conferences. And we have Yuri Oliveira de Lima, which is a production engineer, master in production engineering from COPE UFRJ, and doctor in systems and computer engineering from the same institution. He is currently a postdoctoral researcher at COPE in the project COVID-19 and Automation, a support model for the professional transition of unemployed workers. In 2016, he helped found the Laboratorio do Futuro, And he's also a member of the Brazilian node of the Millennium Project and WFSF. His research on the future of work involves topics such as the impact of automation in Brazil, new ways of working, prospecting future work scenarios, algorithmic management, technological assessment, and professional requalification. In 2019, he founded Labore, a social impact business that uses data science to help public managers, company, higher education institutions, and individuals to understand the world of work and make better decisions. He also acts as coordinator and professor of the computer science course at Universitas Rio de Janeiro. Welcome, and the microphone is all yours.
So thank you. I will share my screen. Just a second. Can you see my screen? So, hello to everyone, and thank you, Alicia, for introducing us. And hello to everyone who is seeing us by the streaming too. And my name is Lyra. I want to thank you for the opportunity to be here, and thank you to my co-workers in this project, Carlos Eduardo Barbosa and Professor Jano Moreira de Souza, who were my advisors in my master's thesis, and Yuri Lima and Herbert Salazar, co-researchers in Future Lab Copy UFRG. And this work was part of my master's degree at Federal University of Rio de Janeiro, and I'm here represent all the team involved in this publication called NERMAP Towards Automating Technology Roadmapping. So this presentation was divided in 5 main sections. Introduction, where you talk about the motivation, challenge, and how NERMAP works. The methodology, where you explain the technique used to generate the roadmap from documents. The system, where you present the system use with examples of how the user can use an NERMAP in an FTA study. The evaluation, where you discuss the NERMAP results. And conclusions, where you talk about the advantages of using the system, your limitations, and future works. So in this section, we will introduce the Future Lab and talk about the motivation, challenges, and how NERMAP works. Well, the Future Lab, Laboratório do Futuro in Portuguese, is a research group created in 2016 at COP, Coordination of Post-Graduation and Engineering, which was part of the Federal University of Rio de Janeiro in Brazil. Our goal is to conduct research on many subjects, to prospect scenarios and design solutions for government, organizations, and society that will help them move towards a more egalitarian, participatory, and a sustainable society for future generations. In the Future Lab, we have 8 lines of research, such as government, work, science, and cities. And moreover, we have a cross-cutting line of research entirely dedicated to design methodologies and software to support future studies. And we recently became part of the Brazilian node of the Millennium Project. Well, technology road mapping, or simply road mapping, or just TIM, is one of the most FTA methods, which can be described as a temporal analysis, which can be about a technology, a product, or a trend. And the main challenge about that is when we have a work with many events composing a roadmap, increasing your complexity. And when, during a study, we are involving multiple data sources to collect these future events. Road mapping is a time-consuming process done by highly qualified professionals. So what's NERMAP? Quite simply, NERMAP is a software capable of semi-automating the road mapping process by extracting phrases that indicate dated events that will happen in the future. So here we have an example of an excerpt of a publication that deals with healthcare in 2050, showing some future events for this area. The main goal of the mapping is finding future events in text by looking for three main structures. The first one, the temporal spaces, which are always related to a specific date or time. The next one, future indicating terms. That means words or expressions that indicate that something will happen in the future, like the words in, by, and the expression for the year of, and many others that may appear. And the last one, and the more important, is that the event that will happen in the future. And a point to emphasize here is that NERMAP does not only find future events with a specific date, as shown in the example, but it can also return text that says something event that will happen in the next years or the next decade. And the system will calculate the specific date, based on the date of the publication. So this is the roadmap format from the previous text, organizing all the events found in a timeline. And this roadmap is an example taken from the system, from the NERMAP. So in this section, I'll talk about the NERMAP methodology, showing the technique behind the system. So how it works? We can explain the NERMAP methodology in three simple steps. First, the user creates a technology road mapping project or a TRIM project and insert files that can be text or a PDF document. And then the software processes each file, extracting time-related events and includes the futures one in a technology road mapping. And finally, the user improves the resulting road mapping and fix errors. The process of NERMAP is simple and starts when the user uploads the documents on the system. That can be papers, reports, or any text or PDF file that deals with the future of a specific subject. As an example here, we have three documents uploaded, Doc1, Doc2, and Doc3. And after submission, they will go through a process divided into four main steps. First, they will be converted to a plain text without any formatting in case of a PDF document. Next, the text will be tagged using the name entity recognition technique. In the following step, the text will be sliced and the future events will be selected. And finally, the future events will be dated to compose the roadmap. So each document uploaded in NERMAP will generate a roadmap of future events, and this document will compose a project called TRM. And the final or the complete roadmap of the TRM will be the composition of the roadmaps of each file, respecting the chronological order of the events. And as we can see here in this short example, Doc1 generates a roadmap with two futures events, Doc2 with another two, and Doc3 with one future event. So the complete roadmap of TRM will join these future events in a big roadmap, respecting the chronological order. So many methodologies, including in the scope of artificial intelligence and text mining, could be applied or contribute to the construction of NERMAP. And the technique used was name entity recognition, an important technique of information extraction that identifies entities for plain text and classifies them according to predefined categories. Furthermore, is widely applied in supervised learning methods for entity classification. So name entity recognition can be implemented by different methods, such as hidden Markov models, maximal entropy models, and conditional random field, which was the method implemented in this work, supported by the Stanford NERMAP framework. So in this part of the presentation, we will show the use of the system, presenting the main features. This is the home screen when the user has just logged in. The screen provides a shortcut to each functionality, such as create a new technology road mapping, workplace to manage files and roadmaps, personal using settings, and a system uses dashboard, allowing the user to change the view for personal or a global user. So the first step in NERMAP is to create a new project or a new technology road mapping, choosing a name, selecting the main area, which can be general or, as an example, education, work, medicine, or transport, and the limit year of the roadmap. I mean, where the timeline will stop. So this is the page to manage the project and the files. Then click on this button. The user will upload the file from the computer and fill this form: title of publication, year of publication, authors, the confiability that the user gives to the source. The confiability to each source is especially important when we are in a study with a different data source to collect the events. So the files of each project that were uploaded are organized, and the user can list them to view their information, such as naming, authors, and process status of the roadmap, edit, remove, or go to a roadmap format from each document. So through this button, the user accesses the complete roadmap of the project, of the TRM, and the result is presented in a timeline showing each future event that was found by NERMAP. And this screen has some features that will be detailed. The first one is hover over each event on the timeline. The edit button is displayed and allow the user actions such as removing or editing the text in the year of the event. So another important function is to be able to analyze the context of each event by looking at the text directly in the document. And this is very important to validate an event or even complete it with more details presented in the publication. And this works for both text and PDF files. So another important function is to be able to add a future event manually without having to upload a document. This is very important when we are in a large study with a large roadmap format, and we want to add an event found manually in a publication. This will avoid generating unnecessary events for the roadmap if the file was inserted in the project. So the roadmap can be exported in different ways and formats, such as CSV, PDF, text, doc, and JSON file, or be made available as an API for use on another system. And the roadmap generated by the NERMAP depends on the inputs provided by the user, which can be quite broad for a subject. So as an example, and a study of the impact of the COVID pandemic on education, where documents dealing not only the COVID in education, but also in education in general, were submitted in NERMAP. We can apply filters by words or expressions and direct the roadmap to a specific subject. In this case, COVID in education. With that, we can think of making trails of roadmaps for several subjects that are inside in a big area. So finally, the system is designed to be collaborative and allow researchers to work together during a study. So with this, the user can invite other researchers to contribute. So in this section, we'll talk about the NERMAP results, analyzing the returning events and their accuracy. So the evaluation of NERMAP included a 3-cycle experiment where the main goal was to analyze the events returned by the system. And the cycles were based on a manual analysis of the publications of the academic journal Futures from the year 2020. And then the same publications were inserted in NERMAP. From this, the analysis was divided into two steps. The first one was to compare the result of the manual analysis with the results obtained by NERMAP. As we can see here from the graphs, the results were improving, with cycle 1 working almost as a test for the other two. Cycle 1 identified many problems with file converter failures and the need for treatments for new cases found, which were both fixed for cycle 2. With this, the results were better in cycle 2, but were still problems regarding the training model, which was improved in cycle 3, obtaining a better result in the validation of the events from the manual analysis with the return of the NERMAP. And the second step was to observe the events returned by NERMAP, check if they were present in the manual analysis, and if they were configured as complete, means that the returned event was complete without any need for adjustment to compose the roadmap. It means was perfect. Partial means that the event was returning completely, requiring the user to refine being able to observe the rest of the text in the document using this function of the system, or invalid. It means that NERMAP improperly returned the event and that should be removed. We can observe through the graphs the evolution of the results. And it's worth noting that the events that NERMAP returned that were not present in the manual analysis represent a great advantage of the system. And through the results of the two analyses, NERMAP reaches 83% of accuracy, validating with the manual analysis. So cycle 3 provides a complete roadmap with 125 future events returning by NERMAP. The majority, 83%, were relevant to the study and could be very useful for a real FTA study. A summary with some future events returning from the journal Futures from the year 2020 that compose the roadmap for cycle 3 shown in this table. We can see future events predicted in different areas, such as work, medicine, astronomy, environment, and many others. So in this final part, we'll talk about the main advantages to use NERMAP, your limitations, and futures works. So why use NERMAP? The system reached 83% of accuracy with the futures database for the year of 2020, and is a system capable of processing many documents in a short time identifying dated events in 1,000 pages from papers and reports in a few minutes. And although the accuracy is not 100%, humans doing the same work would also not have and would take a long time to do. Another point, NERMAP was able to return events that were not observed in the manual analysis. And in addition to the time and cost savings in a FTA study, NERMAP provides a much more consistent collaboration throughout the technology roadmap process compared to the manual execution, centralizing the entire process and organizing information in a single integrated environment. So the limitations and futures works for NERMAP. The system does not include all possible cases for future events, and because of that, we see the need of incorporating new journals to train and expand the training corpus. And new studies using NERMAP have already been initiated to project the future of technologies and carry out a broader review of the entire journal futures. So this is the end of the presentation. I hope everyone understood and liked it, and we are now open for any questions. We have in our contacts, the Future Lab website, the NERMAP website. So thank you very much.
So a question for you guys, Alan and Yuri, right? So first of all, thank you for sharing your work, very interesting work. So if we're looking into the future and you're trying to identify new sources of disruption, how could I use, so because you have, for example, the incidences of COVID in education and etc., how could I use your database to kind of, create hypotheses about future disruptions?
So the database provided for NERMAP is from the user. So we don't searching another database such as Scopus and other years of futures. So the inputs provided for generate roadmaps in NERMAP is from the user that uploaded. So maybe Yuri can be.
Yeah, sure. I think that the tool can be used for that, but I believe that the database actually comes from the sources that the user decides to use. So if you want to use some scientific papers, you can upload the papers that you desire. If you want to upload some news, you can upload the news, because the identification of the named entities can be done in any type of text. But I also think that this scenario that you brought up is really interesting, because you could actually use this platform by selecting papers that deal with the future of education or work or any other subject after the pandemic, and like the ones that were published in 2020 or 2021. And then you could actually find some insights with the use of the platform. So I think it could be used. It's just this detail because of the database, but yeah.
I just saw you guys actually published a report on the future of work and the impact of automation in employment. I'm really going to go take a look at that report, because it's something we need to talk more about, and I want to hear your guys' thoughts on that too.
Yeah, sure.
It's on the site, right?
Yeah, thank you. We actually had a report that we called Working in 2050 that was published back in 2018, if I'm not mistaken. Right. And we recently updated. We done just what you actually asked. that we could use NERMAP, but this time we didn't use it. But we updated this report with the most recent research about the future of work. We're actually making some improvements in the paper, but it is already, we could share this preprint with you, and I think it's really interesting. We also have another paper, which is a literature review about technological unemployment specifically. So yeah, a lot of research about the future of work, and I think NERMAP could be a great tool. And I would like to take the opportunity to invite the WFSF community to eventually test the platform. I think Alan would be happy to have users with experience such as you testing this platform that he created. I think it would be great for him to continue his work during his doctorate too.
So you also have a healthcare 2030 in there, man. You have lots of good stuff. Thank you for coming by and sharing it.
Okay, thank you.
Thank you.
Also, actually, a lot of work from Carlos Barbosa, which was the creator of this research line, Understanding the Future. And whenever we find an interesting topic, and also, of course, the resources in terms of team to work in those projects, we like to create reports about the future of different subjects. So in his thesis, Carlos Eduardo, he created a methodology to explore the future of any subject. So foresight methodology, and also a tool, so which is also interesting, which is called Tiamat. So there's a lot going on in the Future Lab, or Laboratório do Futuro, which we are, of course, happy to share with you.
Thanks again. Looking forward to read more. Thank you.
Thank you.
Thank you, Ron.
So I don't know if you have a moderation here.
Yeah, Alan, are you logged in the platform, in the streaming platform?
Yeah.
Do you know if there are any comments or questions from there?
Just a second.
Because I'm not logged.
Stop sharing. No, you don't have any comments or any question from the streaming.
Okay. So I think we became the chairs for a second. I think it would be interesting, and maybe I can ask you a question. We didn't plan for this, so maybe ask you, how do you see, maybe elaborate some more on how do you see the future of your work, of your platform, and considering the platform that already exist in the foresight environment. So I think this would be interesting to tell also.
So roadmap is one of the most FTA methods now. So Tiamat was being implemented by Carlos Eduardo, carry out many methodologies implemented in FTA studies, such as features view, bibliometric analysis, and brainstorms, scenarios. The next step for NERMAP is improving the road mapping process using more methods of intelligence, artificial intelligence, to improve the results, improve their accuracy, and working in the beginning of the FTA process and the end of the FTA process. Road mapping is in the middle. So working in bibliometric analysis. So today we have to upload a document from the computer. So we have to search a document in Scopus database or Futures database and upload in NERMAP. So we intend to automating this process. So working the beginning of the FTA process now. So and working in the final process. NERMAP today generates roadmaps. So we can generate reports. We can generate scenarios. So that's the main goal of NERMAP in 2.0.
Sure, that's great. A lot to come in the future. And I also like to say something that I usually say when you present the platform, which is I think you have a great accuracy considering that the platform can read, I mean, hundreds of papers in one day, and I can read like 5, 6, and then on the seventh I'll be really tired. So I think this is something to be considered. Maybe you want to do a wrapped roadmap, and this would be perfect. Or maybe you want to combine and collaborate with the machine. So this is also a possibility. So part of the roadmap is done by NERMAP, and another part is done by human researchers. So I think there are a lot of aspects also coming from this future of work analysis that I can bring to this conversation. So if we don't have any more questions, I'm assuming the role of the chair. I don't know, because we don't have anyone here. So I think we can wrap up here. And I think it was great, the previous presentation also. And I thank Ron for his comments. And Alan, I don't know if you have any final words.
Just want to thank you for the opportunity to be here. Thank you, Yuri, for working together all this time, and your comments, your presentation too. Thank you, Ron, for the comments and the questions.
My pleasure. Looking forward